Since the dawn of time, humans have looked at the night sky and asked, how will it all end? Will the universe burn out in silence, collapse in fire, or tear itself apart at the seams? Modern physics tells us that the cosmos is not eternal. It began with a bang, and one day it will meet its end. From the chilling predictions of heat death to the violent chaos of the Big Crunch and the terrifying possibility of vacuum decay, science offers us glimpses of how the universe itself might die. This is the story of the end of everything. To understand how the universe will end, we must first remember how it began. Around 13.8 billion years ago, the Big Bang ignited space and time itself. From a singular point of unimaginable density, the universe expanded first in a violent burst of inflation, then more slowly, forming galaxies, stars, and planets. But this expansion never stopped. In 1929, Edwin Hubble observed that galaxies were racing away from us, proving the universe was still stretching. And in 1998, scientists studying distant supernovae found something even stranger. The expansion is accelerating, driven by a mysterious force we call dark energy. It is this invisible force that will shape the ultimate fate of everything. One possible ending is not fire, but ice. If dark energy continues to drive cosmic expansion, galaxies will drift farther apart, stars will burn through their fuel, and one by one the lights of the universe will go out. In trillions of years, the cosmos will be a cold and lonely place, a graveyard of white dwarfs, neutron stars, and black holes. Even black holes themselves will fade, slowly evaporating through Hawking radiation, until only particles remain. This is the heat death, when entropy, the measure of disorder, reaches its maximum. A universe without energy, without stars, without life. A silent, frozen eternity. But what if the universe does not fade into cold darkness, but instead falls back into fire? Some cosmologists suggest that if dark energy weakens over time, gravity could once again take control. Galaxies would stop receding, and the expansion would reverse. Slowly, galaxies would begin to collide. Stars would crash together, and the fabric of space itself would fold inward. In this scenario, the entire universe collapses into a final singularity, a cosmic implosion as violent as the Big Bang itself. This is the Big Crunch, an end where time, space, and matter are crushed into nothingness. And perhaps, some theories suggest that from that fire, a new universe could be born. There is another, far more violent possibility. If dark energy does not weaken, but instead grows stronger with time, its repulsive force could overwhelm everything, not just galaxies, but stars, planets, and even the very fabric of matter. First, galaxies would drift so far apart that no light could reach between them. Then, stars would be ripped from their solar systems, planets torn from their orbits, and finally, in the last seconds, atoms themselves would be pulled apart. This is the Big Rip, a universe shredded by its own expansion, ending not in silence, but in the ultimate disintegration of all structure. But perhaps the most terrifying scenario of all comes not from stars or galaxies, but from the strange world of quantum physics. Our universe may not be in its true ground state, It could be trapped in what physicists call a false vacuum, a fragile bubble of stability. If that bubble were to collapse, a new, lower energy state would form, and like a spark in dry grass, it would spread at the speed of light, rewriting the laws of physics as it went. In an instant, atoms, molecules, and even the very forces of nature would cease to exist, and we would never see it coming. This is vacuum decay, the quietest, most absolute end imaginable. Even if the universe escapes fire, rip, or quantum doom, there is still one final destiny, an age ruled only by black holes. As stars exhaust their fuel and galaxies fade, the last luminous objects will collapse into black holes. For trillions of years, these cosmic abysses will dominate the universe. Yet even black holes are not eternal. In 1974, Stephen Hawking showed that black holes lose mass through what we now call Hawking radiation. Over unimaginable timescales, they will shrink, flicker, and finally vanish in bursts of energy. When the last black hole evaporates, the universe will enter the black hole era, a cosmos without stars, without light, and without structure. Only silence in the dark. So which of these doomsday scenarios is most likely? Modern cosmology weighs the evidence. The accelerating expansion of the universe, measured by supernovae and the cosmic microwave background, makes the Big Freeze or heat death the leading prediction. The Big Crunch remains possible, but only if dark energy reverses, something current data does not support. The Big Rip depends on whether dark energy grows stronger, a question still unanswered. And vacuum decay? It lurks as a quantum possibility, unlikely on human timescales, but impossible to rule out. Physicists continue to refine these models, but all point to one truth: the universe has a beginning, and it will have an end. For us, these cosmic endings feel distant, trillions of years beyond human reach. But thinking about them forces us to confront our fragility. Civilizations rise and fall, yet we exist within a universe that itself is mortal. Our species, our planet, even our galaxy, all are temporary guests on the stage of time. Some scientists wonder, could advanced civilizations one day escape, migrating to new universes or harnessing exotic physics to survive the end? For now, these are dreams. What we know is this: the universe will not last forever. And our role in this brief cosmic window is to seek, to learn, and to wonder. The universe began with a spark of creation, a flash of light that filled the void with galaxies, stars, and life. And though its ending may be cold, fiery, or silent, it is this very impermanence that makes existence so extraordinary. Every star we see, every breath we take, every thought we form, all are fleeting sparks in the grand story of a mortal cosmos. To understand the end is not to fear it, it is to recognize the fragile beauty of now. Because in this vast and changing universe, our moment exists only once. This is the end of everything.